right, now that we have studied absolute values, let's talk about solving absolute values. We know how to graph them, but we need to know how to solve them as well. So first thing, what do we know about absolute value? Well, hopefully you remember from when you first learned it many years ago that it's the distance from 0. And since it is a distance, it's always going to be positive or 0. So let's take a look at this very simplified equation. Absolute value of x equals 3. If we were to solve it algebraically, we need to consider the distance from 0 in both directions. So we have x equals 3 and x equals negative 3. So if we put a negative 3 in, we're going to get a positive 3 out. So what we're actually saying is the distance x is from 0 is 3 units. Sometimes it's a little bit easier to see on a graph. So we have our center of 0 here, and it's telling us that x is 3 units away from that. So 1, 2, 3 to the right, and 1, 2, 3 to the left. So that statement, absolute value of x equals 3, is telling us to start at 0 as our center, move 3 to the right, 3 to the left. And that's how we come up with these two answers up here. Now, of course, our equations are going to get more complicated than that. Add some extra stuff in there. So let's take a look at ax plus b. We want the absolute value of that to equal c. Now, c has to be greater than 0 based on the definition of absolute value. We can't have it equal to a negative, and we'll talk about why we're not having it equal to 0 in a minute. So anytime that your c value is greater than 0, so a positive number, we're going to split it into two equations. We're going to take the argument and set it equal to c, and then take the argument and set it equal to the opposite of c. Very similarly to what we did up here, x is equal to c, which is 3, x is equal to the opposite. Okay, so let's try one of those. Starting with x minus 2 equals 4. So we're going to write out x minus 2 equals 4 and x minus 2 equals negative 4. Always write both equations first before you solve anything. Reason why is sometimes people write just first equation, solve it, they get an answer, and then they think they're done. So then they move on to the next problem and they totally forget to do the second equation. So if you write out both equations first, then you'll see them both there and you'll know to solve them both. All right, so this one we're going to add 2 to get 6. This one we add 2 to get negative 2. All right, so what does this mean graphically? Well, instead of having our center at 0, like on the first one, this one has been shifted right 2. So now our center is at 2, and we're moving 4 units away from it. 1, 2, 3, 4 to the right gives us a value at 6, and 1, 2, 3, 4 to the left gives us a value at negative 2. But our answers are x equals 6 and x equals negative 2. All right, so please try that again on number 3. I want you to write it out twice, solve it, and then graphically show what you have there. So hit pause and then come back and check. All right, we have 2x plus 10 equals 6, and 2x plus 10 equals negative 6. Well, we will solve this. We have 2x equals negative 4 after we subtract the 10, divide by 2. 2x equals negative 16 after we subtract the 10, then divide by 2. So we know our answers are negative 2 and negative 8. Graphically, where is our center? Well, some people might say 10 or negative 10 because it looks like it shifted that, but this 2 here kind of affects where that center is. Our center is actually negative 5. So you have to factor the 2 out. So really this stuff, this argument in here is 2x plus 5. So it has shifted us to the left 5. And then from either side of that, we are moving only 3 units, not 6. Again, that 2 affects how we move. -8, -2. We divide everything by 2 essentially, and we find our center and our 2 points. So hopefully you at least got the equation solving part right. The graphing on that one's a little tricky because of that 2 being there. If we divide everything by 2, hopefully you can see where we get that center and then to the either side. All right, now let's take a look at an example where it's equal to 0. Remember earlier I said the rule of writing out 2 equations only happens when it's a positive number. Well, that's because we can't say if we have x minus 4 equals 0, we're not going to write a second equation that says x minus 4 equals -0. That doesn't make sense. So we just write one equation when it's equal to 0. So that would be x equals 4. So we just have one answer in that case. Graphically, our center moves us to the right 4, and we're moving 0 units from it. So we're not going either direction, we're just staying right at 4. So our answer is 4. All right, try this last one. Again, hope you're hitting pause quite a bit and then coming back to check. You might have noticed on this one that it's equal to a negative. Absolute value cannot be equal to a negative. So we don't write out 2 equations on this one. We simply say no solution. This one's not going to work at all. Okay? It cannot be equal to a negative number. All right, now we're going to switch gears and try some inequalities. Inequalities are similar to our equations, but they do have some differences. We'll have 2 different types of inequalities. We have the type where our expression is less than a number, and the type where we have our expression is greater than a number. When it's less than, this and is important, and greater or is important because of how we set it up. So when it's a less than, we have a compound inequality here. So we have the opposite of C is less than, whatever our argument is less than C. When it's greater, we have 2 separate inequalities. Our argument is greater than C, and then our argument is less than -C. Less than gives us 1 answer in a compound inequality. Greater than gives us 2 answers. So we want to pay attention to the sign so we know if we're going to have 1 or 2 and how we set it up. All right, solve the inequality, then graph and write your answers in interval notation. Starting off with a simple one here, x is less than 3. Since it's less than, that's when we do the compound inequality. We start with the opposite, is less than the expression, is less than the number they gave us. There's nothing to solve on that one, but we do need to graph it. Going from -3 to 3, because it's a less than without an equal sign, it's an open circle. We shade in between, and then to write it in interval notation, parentheses, -3, 3, parentheses. Well, scoot that up a little bit. Now you'll notice the next one is a greater than. So greater is when we write 2 different equations. X is greater than 2, and x is less than -2. And you don't put them together, because when you graph them on a number line, you will see that they don't overlap each other. They both have open circles because there's no equal to. But here we have x is greater than 2. So greater than 2 goes to the right. X is less than -2. That will go to the left. So 2 totally separate areas that we're shading. So we cannot combine the inequality. Separate inequalities, separate areas. And when we do the interval notation, those will be separate as well. This part on the left, it's going towards -infinity. So we have -infinity to -2. This part on the right is going towards +infinity. So we have 2 to +infinity. And then we connect them with a U, which means union. So we want both of those pieces, even though they are separate pieces. All right, let's try it where we have to solve a little bit. So here we have x minus 2 is less than or equal to 3. Notice that it's less than, so less than telling us that we will have one inequality. So we're going to do the opposite of 3 is less than or equal to our expression, less than or equal to 3. Now we have to get x by itself. In order to do that, you do the same thing that you would do if there was only one thing there. So if we had x minus 2 is less than or equal to 3, we know that we would add 2 to both sides. Well, we're going to do the same thing, but we're going to add 2 not only to the right side, we're going to add it to the left side also. So that allows us to have a negative 1 is less than x is less than or equal to 5. So then we're going to graph that. Notice it's all in one inequality. Both the negative 1 and the 5 are going to be closed circles because there's an equal to, and x is between those two numbers, so we shade in between. Interval notation, we use a bracket when it's a closed circle. So negative 1 to 5 with a bracket. Number 9, we have another less than. So less than, remember, just like this one, negative 6 less than negative x plus 5 less than positive 6. Subtract 5 from all parts. So we have negative 11 is less than negative x is less than 1. Now we still have to get rid of that negative on the x. We're going to divide everybody by negative 1. And when you divide by a negative, your sign switches. So we now have an 11 is greater than x is greater than, oops, I didn't divide that by negative 1, by negative 1. Now, when we write out our final answer, we want to have the lowest number on the left. So I'm going to have to flip the entire inequality there to have negative 1 here is less than x is less than 11. That's my final inequality. Then to graph it, I'd have negative 1 and 11, open circle, shade in between, with an interval notation of negative 1 to 11. All right, where is this used? Well, it's used a lot when trying to figure out an allowable error for some measurement. A lot of times it happens in groceries, like if you have some chips and chips are supposed to weigh 12 ounces, when sometimes they will weigh 11.5 ounces, sometimes they'll weigh 12.3 ounces, and you'll have to know, is that acceptable? The manufacturer determines that, if it's allowable or not to vary in that way. So number 10, we have a 16-ounce bag of flour. It probably does not weigh exactly 16 ounces. Suppose the actual weight can be between 15.6 and 16.4 inclusive. Write an absolute value inequality that describes the acceptable weights of a 16-ounce bag of flour. Well, our middle number, if you think back to the beginning when we were trying to graph these, the middle number that we are shooting for is 16. So that goes inside our absolute value, x minus 16. This number here is always that middle number on that number line. And then it looks like, based on these two numbers, that it's allowing us to differ by 4/10. So we know that that variance is 4/10 away. Now, if you think about the graphing that we just did, do we want all of those weight measurements to be inside or outside of that 4/10? Well, we want them to be inside. So there would be a less than or equal to because it's inclusive. So inclusive means that it's equal to. So just kind of recapping, the 16 is our middle number that we're shooting for. The 0.4, that's the allowable error. And then because we want the values in between, we want everything between 15.6 and 16.4 is a less than. Inclusive gives us the equal to. Now, conversely, if I asked you for what the unacceptable weights would be, this would only slightly change. We would still have our middle number as 16. We would still have our allowable error as 0.4, but we would use a greater than symbol. And this equation would represent the unacceptable weights of the flour. All right, so now for this next one, I want you to read it and try it. So hit pause, see if you can come up with what the equation would be, and then come back and check. All right, so just like last time, we need to find that middle number. So we need to know the number between 84 and 94. So a couple different ways. You just count it. You can add them together and divide by 2 to find their average. But hopefully you find that 89 is that middle number. And from 89, each one of those values is 5 away. So 5 is our allowable error for this basketball court. We want to know the values in between because we want the acceptable possible lengths. So that would be less than. And it said inclusive, so we'll put an equal to sign. If I ask for unacceptable, of course we would say x minus 89 is greater than 5 for the unacceptable. All right, last one, do the same thing. Read through that, write the equations for each one of those sports, and then come back and check. So hit pause, try it, and then come back. All right, so volleyball, we would have our middle value is 270 with an allowable range of 10. And this one, hopefully you read the question carefully. It said it wants to know the values outside the range. So these are basically the unacceptables. So hopefully you used a greater than symbol for the volleyball. If we find lacrosse, let's see, our middle number for that would be 145.5 with an error of 3.5 greater than because we want the numbers outside of the range. And then we have football, x minus 14.5 for that middle number, allowable error of 0.5, again greater than because we want it outside of the range. So that is how we solve absolute value equations and inequalities, and a few fun little word problems to see when we use them.